Okay, so I just wanted to talk about Angelman syndrome. And so basically, there are three ways that you can get Angelman syndrome. The first way is through paternal imprinting and maternal deletion. So, what imprinting basically means is when a certain gene is silenced, and this is usually done through methylation of that region. So, specifically with regards to Angelman syndrome, it's the UBE3A gene on chromosome 15 that is methylated or imprinted um, in the dad. So here there's a spermatid and a secondary oocyte. So when they join together during fertilization to form a zygote, this is what results. You have a chromosome from the dad that is methylated specifically on the UBE3A region. And in the case of Angelman syndrome, now you have a deletion in that same area. So normally the UBE3A gene on the paternal chromosome exists as methylated. However, the maternal gene is normal. So that would be completely normal. However, in the case of Angelman's, you have this scenario where the paternal gene is imprinted and the maternal gene happens to be deleted through whatever process, a mutation or whatnot. So in this case, you have Angelman's. So the second way you can get Angelman syndrome is through paternal uniparental disomy. And to understand this, you have to understand non-disjunction specifically happening during meiosis 2 of spermatogenesis. So if we go back to spermatogenesis and go to meiosis 2, so you start out with the two chromosomes, mom in pink, dad in blue. These are chromosomes 15 from both mom and dad. They double, become sister chromatids here, and then in meiosis 1, these two chromosomes get separated to two different cells, and then in meiosis 2, there are four gametes that form. The four gametes that formed, if they would rearrange evenly, would be one in each. However, in the case of a disomy, you have two of those chromatids that go in one gamete. And in paternal uniparental disomy, you have two gametes from the dad that arrange, two chromatids from the dad that arrange in one gamete. So then now when it comes time for fertilization, you have this gamete, aka the sperm, fuse with an egg, and this is a zoom in of what happens when that fertilization occurs. So you then have two copies of a chromosome 15 from the dad and one copy from the mom. This results in a trisomy. Trisomies aren't viable, so there's a process that happens called trisomy rescue that results in deletion of the extra copy. In this case, it would be from the mom. And so what results is two copies of chromosome 15 from the dad. And as we discussed, chromosome 15, specifically the UBE3A region, exists as methylated. So in this case, that region would be silenced, it would be imprinted, and you would have Angelman syndrome. Okay, so that's how you can get Angelman syndrome, through paternal uniparental disomy. The third way you can get it is by paternal imprinting and maternal imprinting. So it's very similar to the first scenario. You have your spermatid, you have your secondary oocyte, and they form a zygote. And when the paternal chromosome UBE3A region is methylated, as well as the maternal chromosome UBE3A region is methylated, you have silencing of that gene on both chromosomes from both the mom and dad, so it will not be expressed, and that's another way you can get Angelman syndrome. So this was Angelman syndrome, but if you reverse the paternal and maternal for all these three scenarios, you get Prader-Willis syndrome, or sorry, Prader-Willi syndrome. And these are both considered, I guess, high yield for step one. So I thought I'd spend some more time to, really go into it, and hope this helps some people. Thanks.